Okay, let me go ahead and talk about these questions real quick. Okay, now there are a few tips I want to share with you so that you can get a good general idea of how to think about these. Now, what we are expecting is that you are able to add, subtract, multiply or divide these fractions, okay, what we call rational expressions. So here are a few tips. First, you always seek opportunity to factor. Okay, whenever you can factor, you do factor. If you don't factor, if you're not sensitive to factoring these terms, whether it's a binomial or trinomial, then it's going to be a problem. Combine like terms whenever possible so that you can see it better. Write down restrictions before eliminating terms. Okay, because once you eliminate terms, you will not be able to see it. And also when you start eliminating terms, it's also harder to see because you have all these pencil strokes crossing out stuff. You always simplify and reduce. You always simplify and reduce before you multiply things together. You only need a common denominator when adding or subtracting fractions. Okay. Now, this is by far one of the most common things that I've seen in students' work, because students are like, oh, I see two fractions, I have to have common denominators. Well, you only need it when adding or subtracting. Okay, rational expressions. So so that's the thing here. Okay, so I'm going to go over a few questions. So the first one I would like to go over, it's the question 11 on your third page, because that's the stuff we went over last Friday. So so again, you always seek opportunities to factor. So you look at this, you're like, okay, can you see anything you can factor? Well, for the first fraction, the numerator seems pretty simplified, so we're going to leave it there. The denominator, you can definitely factor out the 4. So you have 4 times x minus 4. And for the second fraction, you will see that you can factor out the 2. And after you factor the 2, there's something should trigger your senses, which is the x squared minus 16, which is what? X squared minus 16 can become x minus 4 and x plus 4. Okay, so the difference of 2 perfect square, and actually the denominator could become x plus 5 times x minus 5. Okay, so again, let me just write this down here. When we say the difference of 2 perfect square, it's the a squared minus b squared. It's equal to a plus b times a minus b. Yes. Yes. Okay. And if you are like, wait, what is this? Then I would suggest you to do the FOIL, okay, slowly, and then you will see how the right-hand side is equal to the to the left, and that's how we're replacing x squared minus 25 with x plus 5, x minus 5. Now let me go ahead and factor out the numerator of the second fraction as well. So 2 times x plus 4, x minus 4. All right, now let's take a moment to write down our restrictions. What are the restrictions? X cannot be. You look at this, we say x cannot be 4. You look at this, parentheses, we say x cannot be -5. You look at this parentheses, we will say x cannot be 5. Okay, again, the only reason why we have restrictions is because we do not want the denominator to be 0. If the denominator is 0, then the whole the whole fraction becomes undefined. Okay, you can just try on your own calculator, whether it's on your phone or a graphing calculator. You try to divide by 0. It tells you that it's error, it's undefined, something strange is going to happen. So we do not want something strange to happen. And now you may go ahead and cancel out the terms. Make sure that the reason why we cancel out the terms is because of division. Okay. So x minus 4 and x minus 4, they cancel each other out. Okay, it's just like 2 divided by 2 equals to 1/1, that kind of division, basically. Okay, x plus 5, they will divide each other out. And then we have the 1 right here, and we have a 2 right here, because 2 and 4, they are both divisible by 2, so 2 and 4 becomes 1 and 2. So now just have to make sure that you are focused and you write down what's left. So in the numerator, what's left is x plus 4. In the denominator, what's left is x minus 5. Just make sure you don't miss out any terms, and you're good.
Well, would you not simplify it to x plus 4 over 2x
Minus what? We actually will leave it like this, okay? Because that allows us to see the the factors a lot easier. And in the near future, you will actually want to keep the expression in this form. Okay. Questions on multiplying rational expressions? Yes. No, we just keep it like this. Here? Yeah. Oh yeah, because they are both in the denominator, so you just multiply across. So you're saying this 2 and this x minus 5, right? Yeah. Okay. All right, so that's multiplying rational expressions. And now we have dividing rational expressions. So again, we try to factor whenever possible. So, and when we divide by a fraction, what do? We change the division to a multiplication, and we also do the reciprocal. So let's go ahead and factor first. So for the first fraction, it becomes, by the way, this is question 12 on your third page. So we have x minus 2, x plus 1, and then we have x plus 5, x minus 1. Okay. So you really want to sharpen your skills in factoring. And then, because we are changing the sign from dividing to multiplying, so this x plus 2 becomes the denominator. And the 5x plus 25 would become the numerator, and we can definitely factor out the 5 out of the binomial. And now let's take a moment to write down our restrictions. So what are our restrictions? X cannot be. You look at this parentheses, this pair of parentheses, we would say x cannot be. Everybody? X cannot be -5, because if x is -5, this becomes 0. We do not want 0 in the denominator. We look at this second parentheses, we say x cannot be 1. We look at the third parentheses and we say x cannot be 2. So again, we do not want any of these factors to be 0. So so you look at these parentheses or these factors, and you can tell what x cannot be. And now you can start canceling out terms. So you have x plus 1, with a 5 in the front, and then x minus 1 in the denominator. Okay. All right. So that's how you, yes. Because
she's asking.
I know, because so we only consider restrictions based on the terms in the denominator. That's a very good question, because we do not want to divide by 0. Okay, like just play with your calculator. You can see like 0 divided by anything, it's 0. That's fine. But anything divided by 0, bad. Undefined, yes. And we're about to see a lot more things when what happens when the denominator is 0. So it's for now. Just remind yourself that you do not want the denominator to be 0. Okay. All right. So and now let's turn to the first page. Okay, let's go ahead and take a look at number 1 and number 3. Number 1 and number 3. So for these two questions, for number 1 and number 3, for these two questions, they have the same denominator for both fractions. So you can just go ahead and do the addition and subtraction as indicated. Okay, so you have m plus 2 as the single denominator because they are the same. So you have 3m plus 2 plus m plus 6. So combine like terms. So you have 4m plus 8. Okay, and you can see that 4m plus 8 can be factored too. You can factor out the 4, and then you have an m plus 2. And now, before we start canceling our terms, let's take a moment to write down our restrictions. So for this one, m cannot be -2. Again, we do not want the denominator to become 0. Okay, so make sure you ask yourself a question. And when you are writing all these restrictions, good question to ask, like, why? Why are we doing restrictions? Because we do not want the denominator to become 0. And therefore, your final answer is just 4. Okay. Right, and then for number 3, for number 3, so again, you have the same denominator. So that's great. We don't have to do anything extra. We can just combine the terms, but they are not like terms, so we can just add them. And again, you always seek opportunity to factor, and you see that they are both having y, so we factor out the y from both terms. Okay, now let's take a moment to write down our restrictions. So our restrictions here is, well, we do not want the denominator to become 0. So we can say x plus y cannot equal to 0. And so x cannot be the negative y value. Okay. Yes.
So since we're adding, why would x plus y squared plus x plus y squared in the denominator just equal x plus y squared? Wouldn't it be 2x plus y squared?
Wait, say again.
Okay, so you have 2x plus y squared in the denominator.
Yeah.
So if you're adding them,
Do you add denominators?
right.
Okay. Now this is the unit. It's very interesting. It somehow has the ability to break all your pre-existing knowledge about fractions. Yes. Yes. It does. And this is why you have to reinforce and keep telling yourself, how do you do fractions back in elementary school? Do you add denominators when you have elementary school? Is that, wait, hold on. When we do adding and subtracting fractions in elementary school, we need a common denominator. We keep the same denominator. We don't do anything with the common denominator. Okay, so that's the kind of thing you have to, have to walk very frequently so that you have this consistent idea. Okay, and that's how you build your confidence. And now, so we have this, and there's a very, very common problem. People are looking at this, and people ask, can we cancel out the y? Can we cancel out the y? Okay. Now the question is like, now, like, let me give you a number example. Would you cancel the 2? Okay. Now, I see some of you are shaking your head. But now, for those who are like, wait, what's happening here? Now, you know something right here. That is, the answer is 2/5, right? But if you say, all right, let me try thinking about canceling out these 2 terms, would it still be 2/5? And we say, no, it's no longer 2/5. And that's something wrong because it's supposed to be 2/5. And that's how you know you never ever simplify any terms if there is an addition or subtraction in between. You never ever do any kind of elimination when there is an addition or subtraction. Okay, if you're only canceling out one of the terms here, you just can't do that. Okay, so that's my simple number proof. Okay, if simple number doesn't work for you, then that means the symbols, these letters, will not work the same way either. All right. Right now, for this one, you still have the same denominator, all right, which is great, So we say, all right, let's go ahead and have the same denominator. We have x squared minus x minus 6, wonderful. And for the numerator, we just have to do the addition and subtraction as expected. And just make sure that there's a subtraction right here. And that subtraction will influence the terms that you're writing. So you have x plus 13 for the third fraction, then it becomes minus x minus 13. And so we combine like terms. We'll say, all right, we have x remaining. And then we have -3 remaining. Okay, so x plus x minus x, that's how you have a 1x remaining. Plus 7 plus 3, which is 10. 10 minus 13, you get -3, so minus 3. And for the denominator, you have x minus 3, x plus 2, okay, after you factor out. So now let's take a moment to write down our restrictions. And our restrictions are x cannot be 3, and x cannot be 2. Okay, so and now, after we are done with the restrictions, we can cancel out the terms. X minus 3, they look exactly the same. So we are left with 1 over x plus 2. Yes?
What did you flip it
Oh, wait, -2, sorry. -2, yes.
over 1, right?
Huh? Over 1? Which one?
Or it would just say x and -2.
Yeah, 3 and -2. Okay. Yes. All right now, so yes, it was on the video yesterday already. All right now, so what about if you have different denominators? So just like how you did your elementary school addition, subtraction, you always have to have a common denominator. So now you factor out the second fraction, second fraction's denominator, you're like, oh, so you have x times x minus 1. So for both fractions, they both have x minus 1. So that's good. So you want to have the same denominator. So then you have to make sure that the first fraction would have the first fraction would have the same denominator as the second fraction. So all you need is to do, well, is to multiply x over x. Multiply x in the numerator, multiply x in the denominator. So then they would have the same denominator. So you have 4x minus 4. And then you have 4x minus 1, x minus 1. And now let's take a moment to write down our restrictions. So our restrictions, well, in this case, restriction would be x cannot be 0 or 1. Okay, because if x is 0, this become the whole denominator will become 0. If x is 1, then the parentheses will become 0. So we don't want that. And then they cancel each other out. They're dividing. So your final answer is 4 over x. Okay, 4 over x. That's the restriction. Okay. And let me see. All right, now one last one here. Okay, so so you have to have a common denominator. So for the first fraction, you will need to have a 4 because there's a 4 on the second fraction, so you have to multiply by 4 over 4. And for the second fraction, you need an additional y because there's a y square. So you go ahead and have a common denominator of 4xy squared. And then you will distribute the terms. And then you combine them. And this is on the video from yesterday already. So you can refer to that video for the rest of the work. Okay.